Assalamualaikum and very good morning, girls. Okay, today we are going to continue our discussion on the question 3 and the question 4. Okay, let's not wasting our time. Okay, we go to the question 3. An experiment has been carried out on a plant cell S, which is soaked in solution T. So the result is shown in diagram 3. Okay, so what happened to the plant cell? The plant cell has been soaked in the solution T. And then what can we observe from the diagram here? We can see that the plasma membrane is pulled away from the cell wall. And then the cytoplasm shrink and also the vacuole shrink. Okay, that was the observation from the diagram. Okay, now we go to the question A. State the type of the solution T. Okay, so what happened to the diagram 3? What happened to the plant cell? It is called as a plasmolysis. Okay, plasmolysis occur when we soak the plant cell in the hypertonic solution. Yeah, in the hypertonic solution. Hypertonic solution refer to the solution that has more solute than water. Yeah, okay. Now we go to the B1. Name the phenomenon that occurs on the plant cell X. Okay, so the answer is plasmolysis. Okay, plasmo refer to the plasma membrane. Lysis refer to the breakdown. Yeah, the breakdown of the plasma membrane. It is called as a plasmolysis. Yeah, as we can see here, what happened to the plasma membrane? Plasma membrane is pulled away from the cell wall, right? Okay. Now we go to the B2. Explain how does the phenomenon in B1 occurs. Okay, so how does plasmolysis occur? Okay, the first thing occur is solution T is hypertonic. Okay, I repeat, solution T is hypertonic to the plant cell. Okay, and then what happened? Water diffuse out of the plant cell by osmosis. Okay, you have to state the process involved here is osmosis. Yeah, water diffuse out. Why water diffuse out? Because the solution T is hypertonic. Yeah. So means that the water potential on the solution T outside of the plant cell is low, and inside the cell the water potential is higher. So the water will diffuse out from the higher water potential to the lower water potential by osmosis. Okay, the third one. The vacuole and cytoplasm shrinks. Yeah, vacuole shrink. Why vacuole shrink? Because water diffuse out. And then the plasma membrane is pulled away from the cell wall. Yeah, plasma membrane is pulled away from the cell wall. And the process is known as plasmolysis. Okay, so the question wants you to explain about the plasmolysis. Yeah, okay. So every point here got 1 mark. Yeah, okay. Every point here got 1 mark. Okay, make sure you can remember how the plasmolysis occur. Okay, next we go to the question 3C. Draw the shape of the plant cell after it is soaked in distilled water. Yeah, distilled water in the space provided below. Okay, so you have to remember that distilled water is always hypotonic. Okay, I repeat, distilled water is always hypotonic solution. Yeah, hypotonic solution. And then, okay, what happened when we soak the plant cell that undergo plasmolysis in the distilled water? Yeah, okay. And what happened to the plant cell? The plant cell will undergo deplasmolysis. Okay, so that was the answer for the question 2. Yes, take the process that take place in the cell. We call as deplasmolysis. Okay, then you have to draw the plant cell same like just before the question before, but you will have to you have to draw the vacuole must be larger than the diagram 3, yeah, okay, larger, because what happened here, when the plant cell that undergo plasmolysis immerse in the hypotonic solution, water will diffuse into, yeah, water will diffuse into the plant cell, and then what happened, the plant cell will become normal, return to the normal, yeah, normal shape again. Okay, so that is referred to the deplasmolysis. Okay, and the tips to draw, make sure you draw with a pencil and don't forget to label. Yeah, label also got mark here. Yeah, label also. So diagram without label is 0 mark. So you have to put label, at least 2 label. Right. Okay, next we go to the next question. Okay, question 3D. The erythrocytes, yeah, are put into distilled water. Explain the phenomenon that occurs to the cell. Okay, erythrocytes is referred to the red blood cell. Okay, please remember, erythrocytes refer to the red blood cells. Yeah, okay. So red blood cells are put into distilled water. Okay, remember that I said just now, distilled water is always hypotonic solution. Okay, what happens when we put the red blood cell in the hypotonic solution? Right? Okay, so we have to explain the process. Okay, first, distilled water is hypotonic to the erythrocyte. Yeah, the distilled water is hypotonic to the erythrocyte. And then water diffuse into the erythrocyte by osmosis. Okay, you have to state by osmosis. Yeah. And then the erythrocyte expand and burst. Okay, burst ni maksudnya apa? Pecah. Ya, dia pecah. And this condition is called hemolysis. Okay, lysis refer to the breakdown. Hemo refer to the hemoglobin inside the red blood cell. Yeah, okay, so hemolysis. Okay. Next, we go to the question E. A farmer spray the excess fertilizer to the vegetables in his farm. Yeah, explain the effect to the vegetables. Okay, so as we can see here, the question state that excess fertilizer. When excess fertilizer, that means the solute is more. Yeah, the solute is more. Yeah, okay, and then what happened? Yeah, excess fertilizer. Okay, first point. Yeah, excess fertilizer will make the soil become hypertonic. Yeah, to the vegetable cells. And then water diffuse out from vegetable cells by osmosis. Okay, then vacuole and cytoplasm shrink, plasma membrane is pulled away from the cell wall, and plasmolysis occur. And then what happened to the vegetable? Vegetable wilt. Okay, so this is referred to the plasmolysis. Yeah, plasmolysis process. And then the vegetable wilt. Alright, okay, please remember, when it put the excess fertilizer, it will cause the soil become hypertonic. Yeah, right. Next, we go to the question 4. Okay, question 4a. Yeah, diagram 4 shows the hypothesis of the mechanism of enzyme reaction on a substrate. Okay, and then when we see the diagram here, so you have to remember this one is always enzyme, and this one always substrate. Yeah, enzyme. Why enzyme here? Because it has specific site. Yeah, that only fit with a certain substrate. Right? Okay, so this is enzyme. This is substrate. This is enzyme substrate complex. And this one refer to the products, and this one refer to the enzyme. Alright, okay, so state the hypothesis. When we want to explain the hypothesis, about the mechanism of enzyme reaction, is always lock and key hypothesis. Yeah, lock and key hypothesis. Okay, lock is represented by the enzyme, and the key is represented by the substrate. Right? Okay. And then we go to the 2. What is represented by K, L, and K? So K is enzyme, L is substrate, M is enzyme substrate complex. You have to state the complex here, yeah? And then N is a product, yeah? Okay, then the third one. State two characteristics of the enzyme as explained by hypothesis. Okay, so you have to refer to the diagram when you want to state the characteristic of the enzyme. So do not mention any characteristic, but you have to refer to the diagram. Yeah, refer to the diagram. Okay, what are the characteristics that we can relate from the diagram? Okay, the first one is the enzyme reaction is specific. Okay, we know that the enzyme reaction is specific because the enzyme has active site that only fit with a certain substrate, right? Okay, and then two, enzymes are not destroyed at the end of the reaction. As we can see here, the enzymes are not destroyed. And you can write other characteristic is reusable or can be used again, right? Okay, so that is the answer for the question 4, right? Okay, so right, okay, we are going to continue our discussion on the next class, yeah, with the essay question. All right, okay, thank you, girls. I hope you can understand the question and how to answer the question correctly. Okay, please do more revision on the topic that you think that you are very weak, you don't understand, and you still do not understand the concept behind the chapter. Alright, okay, so thank you, girls. Okay.